generator G1 and generator G2. The ratings and the other parameters for the generators are given. This first generator G1 is of 30 megawatt and its power factor is 0.8 lagging, while the generator 2 is 20 megawatt and 0.85 power factor lagging. The reactance of the generator is 8%, while the reactance of the generator 2 is 10%, and both of the generators are operating at 11 kV, and from that 11 kV generators to generators, they are connected to this common bus bar. This is a common bus bar. So what is happening there? Then we have a transformer T1 which is stepping up the voltage from 11 kV to 132 kV. The rating of the transformer is 80 MVA and its reactance is 8%, and it's connected to a line in turn where the resistance is given in 5 ohm and the reactance is 20 ohm. There is a fault at the end of the line which is labeled as F1. There is another fault after the transformer which is labeled as F2. So what the problem is saying for the power system shown in the figure below, calculate the fault MVA when a three-phase short circuit occurs at the end of the transmission line, the high voltage transmission and the fault currents supplied by each of the generators. So there are two fault locations. That is what is shown in the diagram. Also in the questions, that end of transmission line means F1 at the end of the high voltage terminal of the transformer, meaning here, and we have to find out the fault current supplied by each generator for both fault condition, meaning if a fault occurs here, what's the fault current supplied by each of these generator. If a fault occurs here, what are the fault current supplied by each of these generators. So that's what we have to do. So to start with, as you know, what we have to do, we have to choose the base MVA. So what we can choose as a base MVA, we can choose the base MVA of this transformer or this generator or this generator. They are different, so it's not going to help to find out the common here. There is nothing common, 20, 30, 80. So we can choose anything. Normally we choose the transformer MVA. So let's choose base MVA is equal to 80. You could choose something else, not a problem. So when we have the base MVA, then we start calculating the reactance. So XG1, the generator 1 reactance. The generator 1 reactance will be how much? It's 80 MVA is the base, and then its original MVA is 30 divided by 0.8, so 0.8, which was the megawatt, and then you multiply it by its original 8% reactance, so you will get 17.067%, which means 0.1767 per unit. So that's the reactance of the first generator. That's the reactance of the first generator. So you calculate the reactance of the second generator and tell me what is the reactance of the second generator. X of this generator 2, you calculate and tell me what is its value in per unit. Please calculate and tell me. I'm waiting for you to give me the answer. And please do it a little fast. We are in the 7th week today. And finished. I have to hand over to Dr. Tiako after this. Please tell me the value of the reactance of the generator 2. Can you please put your microphone on? You tell me or you type it there. Hello. Hello. Can anyone give me the answer? Hello. Anyone? Zero 0.34 per unit. That's correct. So X of generator 2 is 0.34 per unit. That's correct. Thank you very much. Others are getting the same value. Others are getting the same value or not. Others are getting the same value or not. Can anyone confirm? Anyone else can confirm this 0.34 per unit? Can anyone else confirm that they are getting the same value? Anyone else? Okay, let's go to the transformer reactance. After generator, we go to the transformer reactance. Looking at the diagram, so X of the T, it remains same. It's 8%. We don't need to calculate anything because its MVA is equal to the base MVA. So 0.08 per unit. Now we need to go to the resistance. Resistance in per unit. So we have 5 ohm times MVA, which is 80 divided by kilovolt squared. So 132 is the kilovolt, and if you put the square of it, get the value you calculate. Similarly, the reactance is 20 ohm times the MVA divided by the voltage squared, kilovolt squared. So you calculate these two value and tell me what will be the can anyone start this too quickly? Saneli Soe. Quick, it should not take long. We will be waiting for 023 and 0.9.092. That's correct. These two values are correct, but I have just little different 0.02296 I have, and I have 0.0918. We don't normally approximate too much. You okay with 3 digits, but if you can keep the more digits, it will give you more accurate results, because at the end of the day, if you have a difference of 5 MBA when you calculate fault MBA, and for that 5 MBA maybe you will be paying 500,000 rand more or less, or your equipment will not be the accurate one. So it's better to use accurate values instead of approximating too much. So your value 092 or 023 is okay. As you see from me, 02296, 0918. So they are okay. But if you keep the accurate values, it's better. In this type of calculation is very important. You will find a huge difference. Now, when we have these reactances, we got the generator reactance here for generator 1 or the generator 2, and then we got the transformer reactance, we got the line reactance, resistance and reactance both. Then we can go and draw the diagram. So the xg1 and xg2 are in parallel with the neutral bus. They are connected to the common bus bar here, as we have on the diagram. Then we show the transformer reactance. Then there is fault point F2 that we show there, and then we have RL that we calculated there, and XL that we calculated there, and then at the end of the line the fault point is shown as F1. This is the reactance diagram that we draw after doing this calculation. So once we have this, we can now calculate for fault at F1. So total reactance up to the fault point. So we say this is, we write it at x total. Let's say x total 1 in this case, because we have two faults, we considering the one, so we put x total 1. So what's the value of this x total 1 in per unit? You tell me. Value. In this case, actually it will be Z, because we have R and XL. Let's say we write it as it. You can change these two impedance. So what we have here, we have two reactances, xg1, xg2 in parallel, and then xt also reactance, and then R is resistance, and then what it will be, we'll have J.34 parallel to 0.17067. These two generators are in parallel. Then it is in series with the transformer reactance, which is 0.08. Then the resistance will come 0.02296. Then the reactance will come, so it's J 0.0918. So how much we're getting? So we'll get 0.02296. That's the resistance. There is no resistance other than that one, and all other are reactances. So it should be J 0.2854. Can you find this? 211. 211 is how, Sahil, we need to find out for all the resistance and reactances. Oh, okay, no problem. Can you verify with the one that I wrote on the screen? Does it make sense what I wrote there, how I wrote there, how those two reactances in parallel in the first place, then all others become in series. Can you verify that one? Can everyone check that one? That those two reactances of the generators are in parallel. So I wrote the J outside because it's reactance, and then the values are in parallel, so it will become 1. After this it will become 1, then the whole thing of this thing will be connected in series. So they are transformer reactance has J, resistance so it doesn't have a J. Is it not 1717? Oh, yes, it's 17. Thank you very much. It's 170 point 0 point, so it should be 0. Sorry, 0.17067. Yes, that's correct now. Thank you, Saneli Sue. 1706. Yeah. Now, are you getting the answer like that I have written on the screen? 02296 and 0.2854, something similar to that. Are you getting that? Then you can find out the magnitude. Don't need the angle. When you find the magnitude, you tell me. You are too slow. I won't be able to finish one tutorial in 45 minutes. You need to be a little faster, please. Point 286, that's correct, but it's to me it's 0.2863. I used to keep 5-6 digits because it makes a huge difference in the end. Don't need to record these things you need to learn in the class. Can you please stop? You don't need to record these things. Can you please stop recording? Who has started recording? You learn these things in the class. That's why I'm spending so much. I'm not even going fast at all. I'm going very slow. I don't have any problem, but you need to learn it here. Don't need to keep it for future. You cannot keep it for future recording it. It does not need any record. So we got that 2863, right? Similarly, we can come back and do the same calculation for fault at F2. So we'll calculate the fault at F2. So the total impedance up to the fault point will be Z total 2. So what are the reactances there up to the fault point is only the generator reactances, and then in series with the transformer. So we can just copy it from there, and that's that. Going to be only J. So how much it will be? How much it will be? Calculate it and tell me quickly. Yes, 1936, 0.1936 per unit. You must always remember that it's in per unit. So J is there, you can keep that J as well. So we got that two reactances for two fault points. So I can go to the next slide, or should I type here? Let me start. Okay, I can keep it here, not deleting. Keeping it outside. I am not deleting it. So we want to calculate the fault MVA1 corresponding to fault 1. So fault MVA1 is 80 divided by 0.28. That's the fault reactance up to the fault point. That's the fault MVA1. And for fault MVA2, it will be fault MVA, so base MVA, and then 0.1936. So we can calculate these two MVAs. Can you calculate and tell me the values of these fault MVAs? Sahil must have the answers in 20 seconds maximum. 10 seconds for each. 80 over 0.2863 and 80 over 0.1936. Can you give me the answer? Two seven nine 279.4347 4272 4272. That's the first one. Second one, fault MVA2. What's the answer for that one? $413.223. These two are correct answer. Now we have the fault MVA. We can calculate the fault current for first one and then second one. So fault current 1 will be what? At the generator bus, we don't need to calculate the fault currents at the terminals. We need to calculate the fault current for the generator bus. Fault current 1 at the generator bus. So how do we do it? We have the fault MVA, which is 279. Fault current 1 we calculating. So we're taking the fault MVA corresponding to that one. That's the fault current divided by the voltage, and we must remember that we have to have that √3 because it's three-phase. So the voltage at the generator bus is 11 kV. So you calculate this fault current, which we called IF1, which we will call IF1, fault current 1 at the generator bus. So the fault MVA corresponding to that fault MVA1, and the generator bus voltage is 11 kV. We are not calculating the fault current at the fault point because that is not asked. We are asked to find out the fault currents at the generator bus. So that's why I take 11 kV, not 132 kV. If we were supposed to calculate the fault current at the fault point corresponding to fault point 1, then we would have taken 132 kV. So calculate and tell me this one quickly. Sahil or Saneli Soe, who is responding fast? So the fault current is 12. Can anyone verify that one? 14.66, that's the correct one. So that's 14.666.7. What is the unit? You didn't give the unit. Ndunge is writing the unit as ampere. Sahil is also writing the unit as ampere, but it's not ampere. This is in MVA. You must remember that this is in MVA, this is in kilo. So it should be in kilo. Can you see what you did not consider? Can you see what you did not consider? MVA is mega and the voltage is in kilo. So what will happen? The kilo must remain there. Kilo must remain there. That's why I always tell you that you must write the unit. Once you write the unit, you will understand if there is something wrong. So we got the IF1. Similarly, we can calculate the IF2. Must always remember that if you write the unit, at the same time there is a less chance of making a mistake. So what is the MVA here? 413.223, and then the voltage and square root 3, that must remain the same, and we're going to find out the value of this current. So tell me this one. 21.6886. We have these two fault currents, IF1 and IF2. Now these two fault currents are actually being supplied by these two generators. We don't know yet which one is supplying how much of this 21, which generator is supplying how much of this 14.666. That is what we are going to find out now. That is what the question is asking us, the IG1 of IF1. So how do we find out? IF1 is 14.6667 kiloampere. So which generator? Generator 1 is how much, supplying how much? Generator 2 is supplying how much? That we have to find out. So how do we find out? Is that you learned it in second year or first year, 14.6667 times the reactance of the other generator. So G1 has the reactance of how much? 0.17, so it will be 0.34. The other one was G2 was 0.34. Yes, so you will need these values here. We'll need these values. We'll need these, the reactance of the generator values. One is 0.17, the other one is 0.34. So generator 1. So what will go there? The reactance of the opposite generator. So 0.34 divided by sum of those two reactants, 0.17067 plus 0.34. Do you know this formula from second year or first year? Can you understand this formula? 14.6667 is supplied by two generators. So I now want to know generator 1 is supplying how much and generator 2 is supplying how much. So IG2, meaning generator 2, is supplying how much of IF1. IF1 is 14.666. This one will be now 0.17067. Does it make sense? This formula, you should know this formula from first or second year, and we are using the same formula here. Can you find it out? 9.6765, that's correct. 9.765 also in kiloampere, and then this should be how much? Is still kilo unit, kiloampere, because the 14.667 is kiloampere. So we're still using, and these are reactances. These units here will be cancelling each other. 34 is in per unit, 0.17, 34, you adding them, so it remains per unit over per unit, they cancel each other, and this kiloampere will remain as it is, so it will be kilo ampere. You can always verify from the equation what should be the unit, and you do it all the time. It's a good question. So 4.9017, you got it from calculation, and if you add these two, you should get that 14.667. if you add these two, you should get 14.667. there might be slight difference because of those decimal points, but they should be equal actually, ideally. And if we don't get them equal to 14.667, meaning something is wrong in our calculation, either of this IG1 or IG2. Does it make sense? Okay, now we got the generator, fault 1 sorted out. Now we want to go for doing the same thing for the fault number 2, IF2, for corresponding to fault location 2, it will be IF2. So what we'll do here, IG1, same thing for generator 1 and generator 2, but it is for fault 2. So the fault 2 was giving an fault current of how much? 21.6886, and all other things will remain same. Still the generator 1 and generator 2. So 21.6886, all other things remain same. We just need to find out the values here. $14.441 is the first one, 14.441 kilo ampere, and the second one is how much? 7.2485. So that many kilo ampere. Again, if we add these two, 14.441 and 7.285, 2485, 7.2485, you wrote there 7.2485, then we should get that 21.6886. You can just double check quickly after doing this calculation, and at the exam you must do it, because we always rush, we just do and press the calculator, and then we forget to check because we rushing to the other question, or we have to submit it in time. But it doesn't take long. You just press to add these two numbers, and when you get this, you know that the calculations are correct to get the two values. So can you now see, when a fault occurs at F1, the fault currents are supplied by each generator, how much, how many amperes, how many kiloamperes they're supplying, we can calculate. When a fault is occurring at the high voltage end of the transformer, not at the end of the transmission line, we can calculate how much of ampere is being supplied by which generator. And if we have more than 2 generators, 3 generators, doesn't matter, we do the same principle. That is why I stopped you, but you still recording, who is recording it? So stopped you to do the record, because you need to learn these things. There is no other way we can bypass or run away from these things. If we run away from these things, we should just run away all the way. Nobody should stop us. Okay, that's that one. Let's go. Okay, I need to, okay, I have 7 minutes today, but I don't think I should start the next one. What I'll do, I am stopping it today. I'll hand it over to Dr. Tiako. He will start from Monday, but I need some extra hours, maybe 3-4 hours. When can I get it? Can you please let me know? Weekend? What time? Give me the time. Tell me, give me some time so that I can plan. I'm having a very busy schedule. Even my meetings continue up until 9:30 in the evening, 10:30 in the evening. I am always. But if you give me a indication that I can do it Friday from 4 to 6 or Thursday 4 to 6, give me 2 days. I don't need more than 2-3 days. I think if you give me 2-3 days time, Friday sounds okay. For a Friday, what time? You give me when you, then I'll book that one for you. I won't take any other. This Friday is fine. This Friday, give me the time. Give me the time in the afternoon time. Okay, let me check what I have there on this Friday. Give me the time. Friday. Today is what day? Yeah, Friday. What time? Okay. Okay, check it and let me know. Thirty, 15, that's fine. For how long? For how long? An hour, 2 hours, an hour or 2 hours. Okay, can the rest of the class say something? What are you saying? From 1:15 to 1:30, 15 minutes, or you saying that we should start at okay, for this chapter I will need maybe 1 hour. Yeah, for this tutorial I need to finish this tutorial 1 hour, a little more than 1 hour, and then I have another chapter to finish that will need 3 hours total. So just let us focus on this one now. Can I give one just little? Is saying 9:35 to 10:20. 9:35 to 10:20. Okay. So can we come on 9:35 tomorrow and 10:20? 9:35, 10:20. Okay. Okay. So 9:35 tomorrow. We'll try to finish this tutorial. Please be a little fast. Tomorrow we'll try to finish this tutorial. I have two more. One is small, the other one is big. So we'll try to finish this tutorial tomorrow. Then we will talk after that what will be the next time, or we'll consult every time when we done something. Then we'll discuss what time we can meet next time. Is that okay? Okay, thank you very much. Then keep well, and I'm going to email every one of you that we having a lecture tomorrow and handing over to Dr. Tiako to take over on Monday. Dr. Tiako will take over on Monday. Thank you very much. keep well and be careful, and especially those, I'm not sure who are in this class now and staying in residences next to the university. Be very, 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 very extremely careful. You have heard what has been happening in the news, like about 20 or more than 20 students got tested positive. So we need to be extremely careful. Just be sure that you are protected, all others are protected around you. Everybody is important, everyone is important. Okay, thank you very much.